So next we are going to study concurrency control protocol. So in the previous video we studied about how to test a particular schedule is serializable or not with the help of a graph. But in order for drawing that graph, we required all the operations of transaction beforehand. But when we are doing the things in practical, we won't get the operations of the transaction. We are getting the transaction only in real time. So in that case we can't draw this type of graph and check whether the schedule is serializable or not, and then if it is serializable, start the execution. Those type of process is not possible in the case of real-time execution. So even though it is not possible, we need to have some mechanism that make a particular schedule that should be equivalent to a serial schedule, or we need to avoid this type of dirty read as well as lost update problem from the schedule. Okay, so for that we are using this concurrency control protocols. So actually I think you studied in operating system regarding certain locks we are using in operating system for process scheduling. So in many cases we found that if a particular transaction read an item, then we have to say that it can to write the item. If the particular transaction is going to write after the read, then no other transaction come in between that. Okay, so that should be a particular one protocol that you can say regarding this concurrency control mechanism. So if particular a transaction starts to write an item, then firstly it will send a read request, and after that it will send the write request. So between these two operations, no other transaction can't get this data item. So in that way we are actually making some locks mechanisms inside the database management system for achieving this. So concurrency control protocol actually is a set of rules that guarantee serializability. So there are different types of protocols. So the first one is two-phase locking protocol. This employs the technique of locking the data item to prevent multiple transactions from accessing the item concurrently. Then another set of concurrency control protocol is use of timestamp. A timestamp is a unique identifier for each transaction generated by a system. That is based on the timestamp, only transaction can access a particular data item. Maybe timestamp shows the age of a particular transaction. So we need to discuss only the first one, the two-phase locking protocol. So actually what do you mean by a lock? A lock is a variable associated with a data item that describes the status of the item with respect to a possible operation that can be applied to it. Okay, so we are saying that this particular item is locked and no other transaction can't write anything. Maybe they can read the data item. So actually it is giving some permissions to transaction. So transactions are always must have lock the data item before doing any operation on that data item. So it may prevent other transaction to access that data item. So lock is actually providing some permissions to transaction whether it can access the data item or not. So locks are used as a means of synchronizing the access by concurrent transaction to the database item. So more than one transactions are executing in a database at the same time, then we need to use this type of lock for making the things handy. So next, different types of lock. First is based on binary lock. So from the name itself you can say there is based on some binary value. So binary lock can have only two state, locked state and unlocked state. So if the value of the locked lock on X is 1, item X cannot be accessed by database operation that requests the item. So that indicates all the data item is associated with a lock variable. Okay, then when particular transaction is trying to access the data item, first it has to check the data item, the lock value of a particular data item, and if the value of lock variable is 1, that indicates that transaction cannot access that data item currently. Okay, it is maybe held by some other transaction, so it has to release, that transaction has to release, then only these transactions can access the data item. So we have to check the value of data item is 1 or not, and if the value of lock on X is 0, the item can be accessed when the requested and the lock values change to 1. So if a particular data transaction going to pick the data item and find that the value is 0, that indicates it can currently access that data item. So it will request a DBMS for accessing, and the DBMS will be granted permission to access the data item, and before granting the permission to that transaction, the DBMS will change the state of lock of that data item from 0 to 1, and we refer to the current value of state of the lock associated item X as lock of X. So it's actually showing some function. Lock of X will return the current value of lock variable. So just to use in following slides, just we are describing a function lock of X. And next type of lock is shared exclusive lock. So first one is binary lock. There are only two states for that lock. Either it is data item is locked or not. Okay, so if it is locked, no one can use, only the current transaction can use the data item. So next we are moving to shared or exclusive lock. So we should allow several transactions to access the same data item X if they all access X for reading purpose only. So if you know that suppose we are trying to read a data item only, so in that case we can give permission to other transaction to read the data item. So so we need to change this binary concept. We are including one more phase into that. If all the transaction need to read the data item, only need to read the data item, then all can access the data item at the same time. Okay, because nobody is changing the data item, the value of or that operation won't create any concurrency problem. So for that we are adding 3 locking operation. First one is read lock. So if particular transaction need to read a data, only need to read a data item, then it will issue the read lock on X. So if the data item is locked by read lock, then other transactions can read the data item, but they can't. Other transaction can't do any write item, write on that the write operation on that data item. And if a particular transaction need to do any operations on a data item, write operation on data item, it has to firstly do write lock and achieve permission to do write operation. So the transaction get only write operation if that particular data item is currently free or it is in ideal state. No other transaction is currently reading or no other transaction is currently writing any item on that data item, and then only a transaction can generate a write lock on that data item. And third function is unlock X. So unlock X means after doing all the operations on data item X, every transaction must unlock that item. So because other transaction may be in queue. So a read locked item is also called shared lock because other transactions are allowed to read the item, whereas write lock item is called exclusive lock because a single transaction exclusively hold lock on that item. And the two-phase locking mechanism, we are using some locking table for keeping track of the lock information. So each the table contains different records, and the records says which data item and what type of lock on that data item and what all transactions are locked on that data item. So the record format is like that. First the data item name X or Y or your data item, so any resource. So next lock, the lock value, whether it is a write lock or read lock. Then number of reads, suppose it is a read lock, you can say that total number of transactions that is currently reading the data item and the details regarding that those transactions. And if it is a write lock, then you can say there is only single transaction, nobody is reading, nobody other than that transaction is reading or writing. So the value of data item is X, the lock is will be write locked, and the value of the transaction, there is only a single transaction, and number of reads is actually 0. Okay, so only that particular transaction can read on write. So when we use the shared exclusive locking scheme, the system must enforce the following rule. A transaction T must issue the operation read of X or write of X before any read. The transaction T must issue a write lock before doing any write operation. And transaction T must issue operation unlock after all read item X and write item of X. That is, if a transaction leaving the execution process, then it has to do an unlock operation. A transaction T will not issue a read lock if it is already hold a read lock or a write lock on the data item. So that means if it is already holds the permission, then it won't need to do the read lock. So already just have permission, and transaction T will not issue write X if it already hold a read or write lock, and transaction T will not issue unlock X unless it already holds a lock X on write X. So if it is not even holding the a lock, no need to give any unlock operation. So next we are going to look into the actually the definition of this read lock X function. So just remind you, a particular transaction is trying to read only a data item, then it has to check whether the transaction is currently in write lock. Okay, and maybe if it can read if the data item is in read lock or in unlocked state. Only it can not get the permission if it is already in write lock. So when the body of the read lock function is if lock of X is equal to unlocked, that indicates the data item is currently unlocked state, nobody is holding read or write lock. Then begin lock of X is equal to read lock. So a particular transaction is going to make a read lock, only going to read the data item X. It first has to make a lock of X equal to read lock. So the value of lock of X is changed, and you know that if we will get into this block, that is this begin end block, only if lock of X is equal to unlock. That means no one is currently holding read. So you have to assign the number of reads. You already saw the data table which contain the details regarding each data item. The number of reads indicates how many transactions are currently reading. So the number of read should be assigned to 1 and then end. So and exit from this function. And if this if condition is not satisfying, you have to check whether other two state is existing, whether lock of X is equal to write or lock of X is equal to read. So first we need to check whether lock of X is equal to read locked. So or maybe one or more transaction is currently read locked that particular data item X. So if it is only if it is having read lock, then other transactions can be added into that read lock. So if lock of X is equal to read lock, then the new transaction need to do only one operation. It has to increase the number of reads, the value of number of reads plus plus. You have to do the plus plus operation. So number of reads is equal to number of reads plus 1. Okay, and it can go and read the data item. Else, that means the current locking variable is not equal to unlocked or read lock, then it indicates that the lock of X is equal to write locked. Okay, so we need to do only the else condition, else that indicates the thing is in a write lock. So the transaction won't get permission. It has to wait until the lock variable is equal to unlocked. So wait until lock of x equal to unlocked, and the lock manager wake up the transaction and go to B. So it will do as an infinite loop. It will always do else operation and wait here. Okay, and next we can do the write lock operation. Okay, a particular transaction can execute write lock only if that particular data item is currently unlocked. Okay, so if it is in read lock or in write lock, that data transaction cannot execute write lock again. So if lock of x is equal to unlocked, that means it trying to execute the write lock, but if lock of x is equal to unlocked, that indicate the transaction can get the permission from the DBMS to access that data item to update or something. So it has to firstly it has to do write lock. Okay, so write lock you have to execute. Else, that indicates it is in some other state. That indicates if it is not in unlocked state, it indicates the x is currently in locked state or write locked state or in read locked state. So the transaction won't get permission to access. It has to wait. So it will be waiting in this loop. And third operation is unlock operation. So if we are doing the unlock operation, then you know that the transaction do unlock operation if the data item is currently held by write lock or read lock. Okay, so two possibilities are there. So if it is holding any write lock on that data item, it has to firstly change the value of lock to unlock. Okay, so if the transaction completed its operation on x, so it has to call unlock x. Then the function is definition is like that: if lock of x is equal to currently unlocked, write locked, that indicates the transaction is currently holding it with the write lock permission. So then begin lock of x is equal to unlocked, that is it change the write lock to unlocked state and wake up one of the waiting transaction. Okay, so if any one of the transaction is currently waiting, you have to wait. If you can wake up that transaction. Else, that else indicates the lock of x is not in write locked state, it may be in read locked state. So there are a few conditions on that. If the transaction is in read lock state, then you know that there may be more than other transaction is currently reading those data items. So the transaction has to check whether the number of reads is equal to or greater than 1. So if it is greater than 1, then that indicates there are more than one transaction. Okay, or if it reduces the value of number of reads by 1, if it reaches 0, that indicates that transaction is the last transaction that hold read lock. Here actually it is implemented in that manner. Here you can see firstly if the transaction is holding read lock, the function will move to else it lock of x equal to read locked, then begin. Firstly it try to reduce the number of reads because it is leaving the transaction, leaving the data item. So number of reads should be reduced by 1. Then it has to check if whether it reaches to 0, that indicates that transaction is the last one. So if number of reads is equal to 0, then it has to move the locking variable to unlock. Okay, then otherwise it can directly move to the end. So if lock of x is equal to number of reads equal to 0, then it has to do an unlock operation, and then it has to wait to call some waiting transaction that need to do some write on this data item. So if after reducing the number of read of x by 1, if it is not equal to 0, then the function will move to end. Okay, and last thing I need to say is conservation of lock. So we can actually convert a particular lock from another state to another state. Transaction that already hold a lock on x is allowed under certain condition to convert lock from one locked state to another. So transaction T, it's possible for transaction T to issue a read lock and then later to upgrade the lock by issuing write lock operation. But there is a constraint, only that transaction is a single transaction that holding the read lock.